Hello, good evening. I'd like to talk about this the wastewater layout plan. Okay, so um, we'll be doing some the the layout plan for the the sewer pipes for this scheme plan, and also the manhole locations. Also, we're going to talk about the design aspect of this wastewater. Okay, for this one is for my alternative scheme, which is different from yours. It's about 21 lots. For the one that you guys are doing, will be 27 lots. So I will have to, I we need to talk about how do we find out what's the the dry weather flow for the sewage. Okay, so first of all, I think we need to um, find the line, the position of the these sewer lines. Okay, so uh, for this for this one is this scheme here. Okay, so um, we at the back in the background actually we have these stormwater pipes. Okay, the stormwater pipes here, the which I have blurred out. Um, we will try not to um, overlap with the stormwater pipes, and also not to be um, too too close to the water supply pipes as well. Okay, so yeah, so um, we could do this layout plan. Either you could run along the roads, or you could go along the edge of the lots, the properties. Okay, so because I think the space is quite premium, so uh, for um, for this wastewater pipes, I'm going to part of it. I'm going to go uh, inside the lots, because I think because have to there are other pipes, the water pipes, the reticulation, and then the stormwater pipes in the footpath. So I think, and also the discharge point, the existing manhole, is on the right hand side here. Okay, so this is a this is existing the sewer pipes, which is 375 polyethylene pipes. So this running from top to bottom from in this direction. So all the sewer pipes need to connect to this existing manhole. Okay. Um, the the invert level of this manhole is, I think it's given um, in the design brief. Okay, so this in the design brief, the 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 one that I revised it, I think recently. So all the sewer pipe to be designed to be discharged to the manhole, the existing manhole. Okay, and then we tag the manhole, the invert level, um, and the invert level that we going that the proposed sewer pipe going to go in is 37.5, and existing the invert could be lower. Okay, so actually it's quite going to be quite deep. Later on we see that it's about because compare uh, compare compared to the existing ground level, it's about 5 meter deep. It's really quite deep. So so yeah, there's sewer the discharge point, and usually we walk backwards. Okay, so we will walk backwards from this manhole, and then we um we walk upstream. For this is a downstream. We walk upstream, and there will be different lines. There will be at least 3 lines. Okay, actually I have done it. I just have to In this one, I just show something from scratch, and then but I'm not going to complete it, all the drawing, because it will take quite a long time. So I will try to draw the sewer pipe first. I'm to check what's my current layer. um, Depth point. So I want to use the project sewer pipes. So the sewer pipes, the color is red, and I show the line red as well. It's 0.3, so it's gonna be a quite thick line. Okay, so I made this current. So from the design, this one from the water care. Um, Actually, water care, they are um, taking charge of the wastewater pipes as well as the water regulation. So therefore, um, for the drawing, this is the water care, the CAD manual. I think they have some guidelines on how to produce the CAD drawings for the CAD drawings for the water care. So I think for the wastewater, they're going to, I think they want the things, the pipes and the manhole to be red in color. Okay, I don't know where is that. Let me see. And the water reticulation to be, I think it's blue or cyan color, blue. I think it's this color. This for the water reticulation. Uh, yeah, here I think it's here. So for the wastewater, we use the red color. For the water reticulation, we we use the this one is blue. Is it blue or cyan? Okay, so this color. So I will attach this. I think the water care, the CAD manual in the Moodle as well. Okay, so I just do a P line. Um, the lots here one to lot 1, 2, 3, 4, 5, and then 6 to 10. I'm going to serve with the um, one sewer pipe. I actually have a choice to whether I this one sewer pipe, whether I should use along the rod 2 or whether it's dual 1. Because the same, I think if I do it the along the rod 2, they could serve both sides from lot 6 to 10 and lots 11 to 15. If I do along the dual 1, it could serve the from lots 1 to 5 and lots 6 to 10. I I pre- I I think I will go for this along the dual one, because the rod reserve is smaller, about 7 meter, whereas this one is about 16 meter wide. So I'm um this one I'm going to put along the edge of this the lots. Okay, so I could do it along the verge. Okay, so but I think we could do it because I'm going to go through the existing ground. So I'm not this one I'm not going to use a challenge. Follow the challenge of this the from zero, this the challenge of this dual one is 0 to 100.99. So I'm not going to use the challenge because it's going over the outside development, and then so I will use the P line. Oops. P line. I'm going to just draw from just maybe about here. Fx. I'm going to go out because this will be a shorter distance. Somewhere down here, because if I do it, I could go along the rods here, along here, because for my case, I don't have any lots to be served along rod 1, because the rod, it can be all the lots can be served along the jaw 1, 2, jaw 1, jaw 2, and then rod 2. So I don't there's no need for me to, because it's just a transmission pipes. It's not going to receive any discharge from any lots along the rod 1. Okay, so but I think for your case, you probably have two. Yours one, you probably have to have a pipes along your rod 1. Think this one, because this one is the so like this rod, this is a rod 1, but you can, so you might have to put you have to put a um the sewer pipe along this rod here, because there's this lots 1 to 8, 1 to 5, and then lot 6 to 11 along the rod 1 on this side. So you need to have a sewer pipe along this rod 1. Yeah, but for my case, because I don't have any lots along rod 1, because this thing like this lot 1, 6, 11, and this one, they can be served by the sewer pipe along jaw 2, rod 2, and jaw 1. Okay, so yep, so I will skip the rod 1. This just bear in mind that I put it inside here, inside the lots, and my the ground level, the proposed platform level will be 43. So the top the the top the the ground level will at below above the sewer pipe will be 43. So you know I so this pipe need to be deep enough, to serve the lots 1 to 5, which has a proposed platform level of 42. Okay, so I need to bear in mind that, so that need to be quite not need to be deep enough to serve the lots opposite. And for I will need to have this one here at the to serve the lots 16 to 21. I'm going to just do a line here. Okay, I'm not sure how to. I just do a fillet. I think I check my radius. My radius is 0. Okay, just check. Okay, and and this platform is 45. Okay, 45, but it's serving only the lot 16 to 21, so it's okay. Because the another line will be here. Will be, I try to get a line which is quite straight, which can discharge. Is quite a straight line that can go straight into this existing manhole. So it will be somewhere along on the verge. So I will just do one here. Okay, I just the I need to join this perpendicular. Okay, just here, because I need to have a manhole here, and then here the exist join go to the existing manhole. Yeah. Okay. So um, this is the sewer line that is going to use. So um, so for what draw one, you'll be go inside the uh the, the lots from lot 6 to 10, and for lot 2, it from this sewer pipe that will serve the lot 11 to 15, it will be along the road verge. Whereas for the sewer pipe down here along draw 2, it will be inside the lot 16 to 21 as well. Okay, so uh, I, I will there'll be three line at least, so three sewer line, like one here, and then another one here, and three, at least three. Okay, three sewer line. So like, yeah, okay, I need to identify the location for um the the manhole. Okay, so I think the spacing for the manhole given is let me see, is about um the spacing is about I think it's 120 if it's 225 to 300 mm diameter. Okay, so ours one probably will be less than 225. I think is we will go for the um, minimum pipe size. I think it will be the 150. 150. Okay, so more than this one connection servicing more than one dwelling units. And these are the sewer pipe. The slope will be need to be greater than the stormwater pipes. So we'll be looking at this one, the nominal diameter 150, and this one 1 to 2 1 to sorry, 1.2%. 1.2% is it will be in term in term of fraction, it will be um 1.2 divided by 100. Okay, so 1.2 divided by 100. So um if we do it like 1.2 divided by 100, actually if we divide the top by both by 1.2 and 1.2, top and bottom, it will be the gradient will be like 1 in 83.33. So 1 vertical, 83.33 horizontal. So that's a slope. So 1 in 83.33 is equivalent to 1.2%. Okay, so we need to have a slope of minimum 1.1 to 1 in 83.33 or 1.2%. The absolute minimum is 0.75, 0.75. So there is that means that um, one point 0.75%. So if divide top and bottom, so this one will be 100 divided by 0.75. It will be 1 in 133. Okay, so yeah, and also I think there's cell cleansing velocity that we need to look into. It will be 0.75 meter per second for sewer pipe. But I think the pipe is I think is probably is too the discharge for this development is quite small. So I think it will not be able later on we'll see it will not be able to achieve that this the because the volume of flow is quite small, but we need to use a minimum the pipe size, which is 150 nominal diameter. So it's quite hard to establish the 0.75 meter per second, but the this uh, the the slope will should take care of the self cleansing of the um, of this the sewage. Okay, so okay. Okay, so the manhole will be this 1.05 diameter. Okay, so it will be let me see whether I got the I think I got some diagram on this manhole. Um, I think I'm not sure where is it. It's okay. So it's okay. So this manhole, this around is the this precast manhole. So around 1.05 diameter, and then the top there it has a heavy cover. Okay, so so uh, so this is a symbol that we're going to use. One round, one bigger circle, and inside there's a smaller circle. So I'm going to use this one as a symbol, symbol for um, the manhole. So I'm going to at this whenever there's junction and whenever there is a change of direction, we need to introduce a manhole. So I put a manhole here, and here we need to put a manhole as well. At the end, we need to put a manhole. Okay, so um, the spacing should be okay because this one will be I think only about 90, about 70 or 18, 90. The most is about 90 meter. Okay, so I'm going to put a manhole at the end. And one here as well, and here as well. Okay, so um, so this is the sewer pipe that we're going um, to use. Okay, so later on we need to label the manhole and also the pipes. The sorry, this pipe here we will label it after we have done some calculations. So anyway, I just going to just borrow this. I'm going to put as um, for this manhole for the sewer for the sewer line. I'm going to put WMH MH1. Oh, I need to put capital WMH1. Okay, so I'm gonna put it here. So because my stormwater is already MH, so I need to differentiate it apart from the color. So for the which is red in color for the sewer line, cyan or blue for the water reticulation. So for this one, I'm going to put to differentiate wastewater MH1. Let's copy this. Gonna put one here as well. Later on, I just put the this one the number. This one the sorry the I going to change later on. This okay. So I think I just number them from up to up to down. So this one is WMH2, and this one I put WMH3. And this one will be WMH4. And this one will be put WMH 5, and then WMH 6. So 1, 2, 3, 4, 5, 6. I'm going to name later on. I don't I'm I'm going to use the UPVC pipe, but I don't know what size. Uh, it has to be minimum 150. Okay, so but I need to double check with later on. The um by the some calculation later on. So so I don't know what size yet. But I'm going to use the later I put the this is just U no U small U PVC. So I'm going to just put probably later on, after calculation is going to be 150 UPVC. Okay. I think I just copy that UPVC is easier. Copy. And then I think need to put one here as well. Here. Oops. Then one here as well. So I need to move this one up a bit. I'm going to rotate this one. Oops, I just rotate. I could rotate 90 degrees. Same thing I'm going to do for the bottom here. Rotate it. Oops, let me try again. Rotate. 90. So we besides the plan, we need to do the long section as well. We need to do long section for 3 lines. So I'm going to do 3 lines. So I call the top one the sewer line 1. Sewer line 1. Okay, I just need to make it bigger, the wording. I think it's I put it 2.5. So the top one is sewer line 1, and the middle I'm going to put sewer line 2, and the bottom I'm going to put sewer line, the sewer line here. So this is the bottom one. I'm going to change to 3. The middle one I'm going to change to 2. Okay, so I got my sewer line in this for my case. There are quite a few options. We could do a sewer line 2 to be from M W WMH3, WMH4, and then existing manhole. You could do that. That's one line. Or for my case, I'm going to try to have this WMH1, WMH2, WMH4, and then the existing manhole that constitute constitute line sewer line 1. Okay, so I want to do this as a one line. So I need to do actually do a long section for this as well. So to do a long section, actually we need to find the existing ground level, and so later on. Okay, so yeah, so that's the plan for this. Later on we need to do the long section, but first of all I need to do some calculation. So I have done the calculation, so I will just show you the calculations. So the design populations is uh, there are 21 lots. 21 lots, and then uh, uh, the this one lot, the house, the building, the this the residential house is either is 3 or 4 bedroom, so we consider 3%, so the 63%. Okay, so actually in the water care or water care, the design guides, so it says that the um, up to 3-story residential, so the design wastewater flow. Okay, so it's per person, the liter per person per day is 180 liters per 180 liters per person per day. Okay. And the number of bedrooms, like for these lots is two, um 3 and 4, so it's under the second row. So the occupancy for the design purposes is 3%, whether it's a 3 bedroom or 4 bedroom, so 3. So we have 21 lots, so we multiply 21 multiply by 21, that give us a 43. Okay, so and then the design, we have to the design um, average dry weather flow, uh, ADWF. So we have designed dry weather flow. Um, we we have to find out the cell cleansing design flow as well as peak design flow as well. So we need to look at this chart here. So the picking factor for the cell cleansing is 3, and picking factor for the peak design flow is 6.7 for the up to 3-story residential development. And then for the dry weather, average dry weather flow, it is actually is the design average daily average dry weather flow is for this example is 150% multiplied by 180 liter per day per liter per person per day. So it will give us and then divide by this one, the 24 hours, because per day we want to change to liter per second, so divide by 24 hours, and in 1 hour there are 3,600 uh, second. One hour is 3,600 second. 60 is by multiply by 60, so that give us in this case for 50%, 150% will give us 0.3125. So this is a design average dry weather flow, and the cell cleansing velocity just this the design uh, average dry weather flow multiplied by the picking factor. Picking factor for dry cleansing is 3, and picking factor for the um, for the peak design flow is 6.7. Okay, so peak design flow is 6.7 and self-cleansing is 3. So yeah, that gives us the peak design flow that we need to use in the chart, in the either is Manning's formula or Colebrook-White the formula chart. We use that to find out what is the pipe to be used on this, and if possible we find out the self-cleansing velocity. Okay, so yeah. So for this for this scheme, the alternative scheme with the 21% people, so the design average dry water flow is 63 multiplied by 180 and then divide by this is day. Okay, 63 lit I think 180 liter 180 is liter per person per day, so we need to change it per second, so we have to divide by the 24 hours and then 1 hour is 3600 seconds, so that gives us 0.1313 liter per second. And the self-cleansing design flow will be just this ADWF multiplied by the picking factor for the self-cleansing. In this case is multiplied by 3, that gives us 0.393 liter per second. And the picking design flow is this ADWF multiplied by the picking factor multiplied by this is 6.7, that gives us 0.8787 liter per second. So in the many discharge, they uh, on the right hand column they actually they want the discharge to be in meter cube per second. So 1 meter cube equal to 1000 liter. So this 0.8787 divided by 1000, that gives us 0.0009 meter cube per second. So from many charts, the sewer pipe 150 UPVC is sufficient. So this is a managed discharge this is a managed discharge chart. Okay. So this right hand column is flow meter cube per second. So our flow actually is only 0.0009. So that is outside the chart. The minimum we have is 0.01, so we're going to use 0.01. So so in this chart here we have slanting line and then we have a horizontal line. Okay, so the flow we're going to follow we cannot go slanting, but we have to go horizontal. So the closest to 0.0009 is 0.01. Okay, in this case the minimum flow. So we got that, and then um, the line that we're going to use is we're going to we we try the bare minimum one one in this 1.2%, which is 1 in 83.3, so it's about here 83.3. So we have a red line here, just a horizontal line at the bottom, and then with this, and then we will need to find the what's the size of the pipe. So the pipes here, the the pipe that that will need to be used is this one, no 150. Okay, because this one here, this is the bare minimum one. I think the 150. Okay, if your line, the red line here is between the 150 and 225, is if your the point here is somewhere here, then you need to use the bigger one, which is 225. Okay, so um so our discharge is much smaller, 0.0009, so it's way below. So actually but because we don't have that, we don't have anything below, so we have to use the minimum of 0.01. Okay, so but our actually is much smaller. So this one, the green line here, from here it probably is not correct for this for our type of discharge. Okay, so probably will be in this case it will be below 0.75. So we don't have any value because the 0.009 is way down here. Okay, so we said we look at that. We're happy that the pipe is to be 150. Okay, the material that we're going to use will be UPVC. We could use the PE as well, but I think UPVC probably is, in terms of cost, this is cheaper. So we're going to use a UPVC. So that's the design aspect of this to find the actually this is to find the discharge into um, here into existing pipe because um, the 21 lots actually is it's not along the draw 1, draw 2 or draw 2 or the rod 2, but it's for the whole thing. So that actually is the flow that we're going to be along this line here between WMH5 and the existing manhole. So yeah, so that's the this the average dry weather flow. Okay, so we we're happy that the line is 150. Okay, 150. So actually um should have done something draw here. So we can label all this as 150 UPVC, 150 UPVC, 150 UPVC, and then the one this line here also 150 UPVC, and top there is 150 UPVC as well. Because we check that the for the 21 lots. So this one all the this gray water will pass through this pipe, here pipe. So is this one 150 UPVC is also sufficient. Okay, so go into the existing manhole. Yeah. So we just draw the line here. The one lot we can just put a connector pipe here, and for this this pipe along the draw one, actually we need to serve the other side as well. So we need to provide connector pipe for each lot so that they can just the grey water from the toilet, from the kitchen, from basin, they can go into the sewer pipe. Yeah. Uh, okay. So we have this we already calculated this. We have calculated the size. So 150 is okay for all the lines. Okay. So now we are in the process to do the long section. Okay, to do the long section, actually we need to um, quite different from the rodding. So we need to have more um, um, more more this one the values. Uh, Here we don't use the channage, we use a distance because we don't have a channage because channage we only use it along the rod. So this one is go over the border even. So we use the distance. We measure from we start from the manhole here one. um, so I'm going to use the manhole. Let me see. So manhole one for this line, they're going to consider manhole one. This one WMH2, and then the WMH4, and then the existing manhole. So actually, I'm going to just make into one entity because I need to um, find the channage, do the channage along here as well. So I try to at the moment it's not joined. So what I can do is that I need to break this line so that to join to this line. So I go to break, spread, spread that, and I need to fillet that. This one and this one. Okay, so this is one entity, and then I think this one is, yeah, this is one entity. So I think, yep, I think they all join up, all one, all this is a one, what's it called, continuous line. So I need to put I need to find a challenge, because I, not the challenge, the distant point, because I need to, in my long section, um I'm going to find actually I've drawn the manhole. So we're going to establish the manhole position. uh, want to see what's um, the from the first manhole, what's the distance from the first manhole to the second manhole, and from second to the third, and third to the fourth. So we need to identify the distance from the first manhole. First manhole is distance 0, 0. Okay, and the second manhole, in this case, measure is at a distance of 80 81.57 from the first manhole, and the third manhole um, is 132.86 from the first manhole, and the last manhole here is 150.63 from the first manhole. So for the long section, we need this just for sewer, for the long section for sewer line 1. So later actually you need to do sewer 2 and 3. If you need to do rod 1, probably you have another long section as well. So I will do we will do the distance, and then the ground level, and then the rod level, because here our sewer line for this sewer 1 is this is along the platform, the platform of this lots 6 to 10, and then it go outside the boundary, and then go along here, and then into the existing manhole. So this one probably we can along this draw one, we can see the existing ground level or the proposed platform level, and then the rod level. So it will end at this point here. Okay, so we need to mark out where is um, where is the distance. So actually we try to find the challenge as well. Like we have 0, 30, 60, 90, 120, and then 150, and then last one is 150.63. Okay, so what we can do is that we do the, I just copy, I think for the to save the time, I think I just copy this line and this line from here. I'm just going to put it here. Okay, so I'm going to do the array path. I'm going to cover the whole line here, the whole line from here until the existing manhole. So I'm going to do array path, path. Okay, so enter, and then I'm going to array path this small piece of the distant markers. Okay, and select object all done. Select the path curve. So this is a path curve. So now we need to set the interval between the items. So we got these items. We need to put items, and then it will ask us the distance, specify distance between the items along the path. This distance is we actually want to set the just like the rod. Yours one could be 25. Mine is I'm going to put 30. Mm, what is it? Okay, so it's 30. So this one I'm going to actually I'm going to mark them up, like 0, 30, 60, 90, 120, and so on. So now there are one block. I can't do much thing. Um, this one, and so I need to explore it. Explore it. Now you can change. So this one will be 30. So just move this one a bit further down. So this one will be 60, and then this one is going to be 90. This will be 120, and 150 here. So we need to find the challenge for the different parts as well. So this one, I just copy this one. So we need to find the distance line between these 2.49. So it will be 142.49. Okay, let's move it up. And then this one will be let's copy this 90. I don't know, so how is the distance? I just going to rotate that. Because I don't want, I want it to like that. So I need to find out what's the challenge. So what I can do is that I just measure distance. I think align. So 73.87. 73.87 plus 60 will be 83.87. 83.87. And same thing we do for this one as well. How far is it from here to here? I just copy. I think I will just show the, because it take probably I don't want to take too long time. So actually I've done that earlier. So I got this uh, so I have this the challenge. You can see that 0, 30. I just do it for silver line one. 0, 30, 60, 90, and 120, 150. And also I identify the I think it's up there. I've done that as well. Identify the challenges at the this manhole is 81.57, and this one this manhole is 40 what's it 132.86, and then the last one the manhole is 150.63. So it's a slightly different. I know just now I did, I think it's slightly different. Yeah, so this one's I think 152.49. Okay, so now we need to um, find out the at the various point here, and then a various point here at 30, 60, 90, 120, 150, and also at the above the manhole, because we need to identify, we need to find the invert level of the manhole, as well as the from top to the invert level, how deep it is, what's the distance. So to find this point here, actually I need to turn on the contour. I think the contour is, so when I turn it on, then you can see that, all this contour line, what is the existing ground. This, because this here is this is about 42.5. This is the interval of the contour is 0.5. So this is 42.5. And then you can see that here, this line is 42.5, this is 43, this line is 43. So we can find it, interpolate the um, 30 here, the change 30. What is the, probably it's about 42, 42.7 or 42.8, this is 40, this one is nearer to 42.5, so probably 42.6. So, and then this one, this channel here as well, so we need to uh, find the distance as well, I think. Yeah, the height here, this one is 42.5, so actually this one about 42.1, maybe the ground level. Same thing for the main WMH4, and then even the existing manhole, what is the height. So actually we have done it here. So I have the distance from the first manhole, 0, 0, until the end, which is the one that discharged into the existing manhole, which is 150.63 for this cell. Okay, so I cover the regular changes, not changes actually, regular distance, because we're not having the rod, the involved. So we have this from distance, 0, 30, 60, 90, 120, 150, and the end distance as well. Okay, so we also need to have the ground level, because for this one we have three types of surface. We have the rod level, the blue one, the rod level along the draw one, and then the platform level, proposed platform level. Because we run the sewer pipe along the edge of the boundary, the edge of the lots. And also, we have this one is overland. It's not inside the lots, which is existing ground level. So we have to do the ground level. So ground level, I think with the red line. I think in this case we consider the platform, because we that would be the ground, because we're not going to consider the existing ground level. Um, Actually, I think we do the ground level. Yeah, the ground level, whether it is we do it. Um, this one will be the ground level is 43, because along um, this one, the lot 6 to 10. So we check the platform, this 43 is a suitable one. So 42. Okay, so besides the ground level, rod level we can determine, because that's only from the draw one, from here until not the until, I think it's about change about 79.26. So the ground level, so this one, the rod only from here like in this case we WMH1 until the end of at the boundary of the lots. So okay, we only consider that. Okay, so we have the rod level, and then we need to have another role, which is to find the gradient and the pipe size. Gradient. What's the gradient? You know, the minimum is 1.2%. So what is this one? So we have this at 2.14%, 2%, 2.1, 2.01%, and 1.24%. Besides that, we need to have the invert level. So um, invert level, we work from backward from the existing the manhole. Existing manhole actually is given is 37.5. So we need to move it from we do it from here until the next manhole and then so on. Okay, so we need to walk backward and make sure that we satisfy the radius, which is 1.2%. So we just do it from here to the next manhole, and this manhole here, I think it's WM, I don't know. We need to actually need to label it as well. So and then to the next one, and then this manhole to the next one. So we need to have the invert level. Just the invert level, I think you just take as the bottom of uh, the drain, which is I think you know is similar. The um, bottom of the manhole is the same as the bottom of this the pipes. So we'll be doing we will um, we we got this the existing and then the ground level, and then you know the red one is the existing ground, and then this this one will take care of the platform of the um just turn off the thing, I think the contour. I need to turn off the contour so it can be see easier. Okay, so um the invert level, you know, we calculate we I put the ground level as well. The invert level is to be walked from the existing ground, so existing manhole, and then we walk backwards and then it's going up. So so we walk backwards. We start from 37.5. Where is that? 37.5. Yeah, 37.5 the invert level. We start from here and then to the next manhole. We maintain it 1.4% because I want to go it deeper because there are two lines, silver line 2, silver line 3. So we might as well we get it deeper so that you won't um the other two lines that make sure that can go in. Okay, so from this manhole to the first one is about 2.14%, also 150 UPVC, and further downstream is also 2%, 2.01, and also 150 UPVC. So we do this we established the 37.95.5, so we just walk backwards. Okay, so to the um this the gradient we keep it between 1.2 I think to 4 I think under 2% above 1.2%, and then the other constraint is that it need to be not too shallow, so we need to put it like 40.5. So I in this case I put it 1.5 meter deep from the platform, 1.5 meter deep from platform. So hopefully the other side it can go in as well, because I think this one the invert level is 40.5 and invert level. So the other side the platform is 42. So hopefully it can go into this 40.5. So I do all the yeah all the top one. I just only things that we do is the invert level of the manhole, the 1, 2, 3, 4, 4 manholes. We need to know the invert level of the manholes, and also from uh, the the top rod, we can find what is the depth to the invert. So that means that for here, the depth to the invert will be from the proposed this the proposed platform level. Yes, that is for the um, these are lots here from lot 1 to 5. Okay. Okay, so we have this. Actually, we started with the when we do the drawing, one same scale, horizontal and vertical. The same we do it same scale. Okay, so the same scale. Later on, we're going to pull it up to this direction, which is the vertical is 5 times more than the horizontal. The horizontal is 1 in 1,000, so 5 times bigger. That means that like 1.1 to uh, this is 5 times bigger. So in 1 in 200. Okay, so the horizontal scale is 1 in 1,000. The vertical scale have to be need to be 5 times more. So that means 1 to 200. Okay, so we from here we got this, and then how are we going to do this thing? So what we do is that we just I just for example I just copy this um I do another one, copy. Oops, sorry. What I do is that I block it. I need to block this thing. At the moment it's not blocked, so I mat block. Draw mat block. I need to put a name because I have done it quite a few times, so I put it something that is never been done before. BM and objects. Sorry, not that one. Let's do this one first. The pipeline, and also need to cover the manhole. And this one. And enter and convert to block. Yes. So it should be everything is in one block now. Yeah. So it's that's correct. Everything in one block. So what I can to do like to do this uh to blow up the 5 times vertically. So from here I highlight it, and then I go to modify the properties. So here under geometry, actually XYZ. So this one the going up is actually is Y. So I just change it to 5. Oops. I think I have to do it again because I didn't pick the point. Let me see. I just do it again. I think I have to redo it again because the block is not correct. Okay, so I didn't pick the point. So make block again. Make block. I do another BN. Just now it's BM. And then select objects. Oops. Select that. And then select the manhole. I need to pick a point just here on the top of the table, and I convert into block. Okay, so this is a block. And now I go to modify properties. I highlight this. Now I click 5 for the Y. I put 5. Now you can see that it's just going up there. Okay, so this is the scale. This one is 5 times from the earlier one. This one, the 5 times vertically. So I need to um, explore it so that I can extend the thing. I just do it again. Explore, enter. So these are separate lines. So I just extend, and then extend to, I think I want to extend to the top here. Oh, let me see. Extend. I need to do the boundary to top. For top here. Okay, enter. And then I just click this line. This one. Oh, I missed out one. I have to bring it up there. This one can't do that. So this one extend. I need to do it. This one. Oops, sorry. Try again. Extend. Boundary. B is a boundary. And then just extend the bottom one. Oops. Extend. Extend. It should be from here. Oh, I need to specify the boundary actually. B for boundary. And then it should go up now. Okay, this thing here is I need to do it now. So yeah, it should go up there, but I just go in to the property. I think hopefully it can be done same thing as well. I probably need to do the map block also because it will fly up too high. Map block for that. Map block, where's block? I do again. I think it's BNB. I think BP. It's just a block, but I think I just do it again. And then a pick point because I need to pick the point. So this point here, convert into block. Okay, so this is a block. Now I do the go to property and I highlight this. I put 5 times. Hopefully it will go up there. Yep. Okay, it does go up here. Okay, so yeah, before that actually I need to tell you that this one I need to draw the various the this what's it this this manhole. So what I do is that, you know, my diameter of the manhole is 1.05, and then the height I just measure it from here, like each one, you know, the height from this point here, from the bottom until the top of the surface. So I just measure. Actually, probably the same. You can measure. Like this one is 3.75. Each is measured already. So this one, the dimension is the same thing. 5.3 is the same thing. So actually, I just draw a line. For example, I just do a P line. I want to do 3.75 high manhole. I just add 3.75, and then the diameter of the manhole is 1.05, 1.05, and then going down 3.75, and just cross the thing. Okay, so and then I just move it, this thing, and I pick the middle. I just put it F8. I just move it here at the bottom, the bottom of this line. So yeah, that's position. So actually this is double, so I just put it out again. So yeah, I got all these things here just like this. I did it in the horizontally and vertically, same scale 1 in 1000. But after that, then I pull up I block it, and then go to the property, and then I pull up the Y scale 5 times to 5. The rest is 1, and then I label them. This is rod level, this is the proposed platform level, and then this is the existing ground level. Yeah, so I got all these things. This is for the long section, and then I need to label the gradient and the pipe size. So this one is from here is 2.14%. The next one is 2.01%, and then 1.24%. So this thing is just we know the distance is um one is at 81.57. The horizontal distance is 81.15.57, and the change in elevation is actually is the invert level, which is 40.5 drop to 38.57. So 40.5 minus 38.75, that gives me 1.75, and then you divide by the horizontal distance, which is 81.57. That gives me 0.02121421. So multiply by 100, that gives me 2.145. Okay, so that's uh, the 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 gradient of this the pipes here, and then the gradient of the pipe the next between these two manhole is something we do a something 2.01, and then finally between the last two manhole is 1.24%. Okay, so the manhole, these are the manholes. So this manhole is in the along the jewel. This one is along jewel 1, and this one is outside the boundary of the property, of the development, and then this one outside as well, and this one is existing manhole. Okay, so and then which I don't know the depth of the manhole, but we know that it's going to discharge at the point of 37.95. 37 point, I think, what's that? 37.7, 37.5 is going to this the point of discharge. So yeah, so that's all about the sewer line, the wastewater pipes. We did the layout plan first, and then we do the calculations, and then we do a long section. Yeah, and then actually some of this thing here I just draw the connector pipe for each lots. So the the property the people in the property, they will just connect their own sewer pipe to this connecting pipe, and then this sewer line also serve the other lots from the other side. I need to provide connector pipe as well for each lot. Okay, and yeah, so this is for the sewer line 1, and then actually need to do sewer line 2 and sewer line 3. Sewer line 3 be from here and then go upwards to meet until this WMH5. Yeah, so that's all for uh the wastewater. Okay, for the drawing, the design and the drawing. Okay, thank you.